today? I hope you're fine, healthy, and safe. Again, I am Teacher Xiao. I welcome you to another episode of Mathematics 10 lesson. Today, you will learn about arithmetic mean or means and arithmetic series. Let's start the lesson by doing the first activity. The activity is a review of your past lessons. First up, determine the common difference of the following arithmetic sequence. First, 3, 11, 19, 27, 35. What is D? If your answer is D equals 11, then you are correct. Now what about the common difference of the arithmetic sequence? Negative 2, 7, 16, 25. If your answer is 9, then you are right. Let's have another problem. What is the common difference of the arithmetic sequence? 17, 11, 5, negative 1, negative 7. If your answer is negative 6, then you are correct. Now, let's have another set of activity. Study the given arithmetic sequences. Determine the term that will be placed on the blank. First sequence, 7, 11, 15, blank, 23, and 27. The answer is 19 because the sequence has a common difference of 4. Now, what about the sequence negative 8, negative 3, blank, 7, and 12? What number must be placed in the blank? The number is 2 because the sequence has a common difference of 5. Let's have the last item. What number must be placed on the blanks for the arithmetic sequence 3, 6, blank, a blank, and 15? What is your answer? If your answers are 9 and 12 respectively, then you are correct because the arithmetic sequence has a common difference of 3. The last activity allows you to find the missing term or terms in an arithmetic sequence. Hence, you are now ready to formally define arithmetic mean or means. The terms between any two non-consecutive terms of an arithmetic sequence are called arithmetic means. Consider the arithmetic sequence 3, 6, 9, 12, and 15. The terms 6, 9, and 12 are the three arithmetic means between the terms 3 and 15. Now, let us formally define arithmetic mean or means. If A, t sub 1, t sub 2, then t sub m, then b form an arithmetic sequence, then t sub 1, t sub 2, until t sub m are then the arithmetic means between A and B. Let us consider some examples for us to illustrate arithmetic mean or means. First, Insert 5 arithmetic means between 4 and 22. Let us look into the solution. Let t sub 1, t sub 2, t sub 3, t sub 4, and t sub 5 be the 5 arithmetic means between 4 and 22. Thus, 4, t sub 1, t sub 2, t sub 3, t sub 4, t sub 5, and 22 form an arithmetic sequence with the first term a sub 1 equals 4 and a sub 7 equals 22. Now, by using the formula of an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, we have 22 equals 4 plus 7 minus 1 times d. Now, subtract 7 minus 1. So we have 22 equals 4 plus 6d. Now, adding negative 4 to both sides of the equation, we have 22 minus 4 equals 60. Simplifying, we have 18 equals 60. And then, multiplying both sides of the equation by 1/6, so we have d equals 3. So, from a sub 1, which is 4, add 3, which is our d, so we have 7. Add 3 to 7, we have 10. Next, add 3 to 10, that's 13. Continuing, we have 13 plus 3 equals 16. 16 plus 3 equals 19. This therefore implies that the 5 arithmetic means between 4 and 22 are 7, 10, 13, 16, and 19. Now, if there's only one arithmetic mean that is to be inserted between A and B, then the arithmetic sequence A, T, B is formed. The number T is the arithmetic mean between A and B. Because ATB is an arithmetic sequence, it means that T minus A equals B minus T. It follows that T equals A plus B over 2. Let us show one example of inserting one arithmetic mean. What is the arithmetic mean between 38 and 98? Let us look into the solution. Let A equals 38 and B equals 98. Then, the arithmetic mean, which is T, is, using the formula, T equals A plus B all over 2, we have T equals 38 plus 98 all over 2. Simplifying, we have T equals 87. Therefore, the arithmetic mean between 38 and 98 is 87. Let's have more examples on arithmetic mean or means. If 3 arithmetic means are inserted between the terms 5 and 21, what is the second mean? Let's look into the solution. We write the sequence as 5, blank, another blank, and another blank, and 21. Consider a sub 1 equals 5 and a sub 5 equals 21. So solving for D, we have, using the formula, a sub n equals a sub 1 plus n minus 1 times D, we have 21 equals 5 plus 5 minus 1 times D. Simplifying, we have 16 equals 40. Simplifying further, we have D equals 4. To obtain the second mean, simply add the common difference 4 in the first term. Therefore, the second mean is 13. Let us have another example. Insert two arithmetic means between 5x plus 3y and 8x. Again, let's look into the solution. Let t sub 1 and t sub 2 be two arithmetic means between 5x plus 3y and 8x. Thus, we write the terms of the sequence as 5x plus 3y, t sub 1, t sub 2, and 8x with a sub 1 equals 5x plus 3y and a sub 4 equals 8x. Again, by using the formula of an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, we solve for the common difference d. That is, a sub 4 equals a sub 1 plus 4 minus 1 times d. By substitution, we have 8x equals 5x plus 3y plus 4 minus 1 times d. Simplifying, we have 8x equals 5x plus 3y plus 3d. Applying the addition property, we have 8x minus 5x minus 3y equals 3d. Now, multiplying both sides of the equation by 1/3, we have 3x minus 3y all over 3 equals 3d over 3. Simplifying, we have now d, which is equal to x minus y. To find the first arithmetic mean, which is t sub 1, add the common difference d to 5x plus 3y. So, t sub 1 equals 5x plus 3y plus x minus y equals 5x plus 3y plus x minus y. Therefore, t sub 1 equals 6x plus 2y. Now, let us solve for t sub 2. T sub 2 equals 6x plus 2y plus x minus y equals 6x plus 2y plus x minus y. Therefore, t sub 2 equals 7x plus y. Therefore, the two arithmetic means between 5x plus 3y and 8x are 6x plus 2y and 7x plus y. Now, it's your turn to find the arithmetic mean or means of some arithmetic sequences. First, find the arithmetic mean between 7 and negative 15. If your answer is negative 4, then you are correct. Let's have another one. Insert 3 arithmetic means between 18 and 4. So what are the 3 arithmetic means? If your answer are 14 and a half, 11, and 7 and a half, respectively, then you are right. Let's have one more problem for you to answer. Insert 2 arithmetic means between 2x minus 4y and 5x plus 5y. Again, give us your answer. If your answer are 3x minus y and 4x plus 2y respectively, then you are again right. After finding the arithmetic mean or means of an arithmetic sequence, This time, let us find the sum of the terms of an arithmetic sequence. The sum of the terms of an arithmetic sequence is called series. Therefore, it follows that the sum of the terms in an arithmetic sequence is called an arithmetic series. The general rule for an arithmetic series can be stated as follows. The sum, S of n, of the first n terms of an arithmetic series is denoted by S of n equals n over 2 times a sub 1 plus a sub n, or S of n equals n over 2 times 2 a sub 1 plus n minus 1 times d, where a sub 1 is the first term, a sub n the nth term, n the number of terms, and d is the common difference. Now, let us have some examples for us to illustrate finding the sum of arithmetic sequence. First example, what is the sum of the terms of the arithmetic sequence 2, 7, 12, 17, 22, until 72? To find the sum of the terms of the arithmetic sequence, we use the formula S of n equals n over 2 times a sub 1 plus a sub n. The formula requires the first term, which is a sub 1, and the last term, which is a sub n, and the number of terms, n. Since the number of terms in the sequence is not given, we need to solve for it. So, a sub 1 equals 2, a sub n equals 72, then solving for d, we have 7 minus 2 equals 5. So, using the formula a sub n equals a sub 1 plus n minus 1 times d, we have 72 equals 2 plus 5 times n minus 1. And then we have 72 minus 2 equals 5 times n minus 1. Simplifying, we have 70 equals n minus 1. And solving for n, we have n equals 15. Therefore, the arithmetic sequence has 15 terms. Then, we have S of n equals n over 2 equals a sub 1 plus a sub n. So we have S of 15 equals 15 over 2 times 2 plus 72 equals 15 over 2 times 74. Multiplying, we have the sum of the first 15 terms is 555. Let's have another example. What is the sum of the first 26 terms of an arithmetic sequence whose first and fifth terms are 3 and 27 respectively? Let's look into the solution. Since the first term, which is a sub 1, is 3, and the fifth term, which is a sub 5, is 27, we can find the common difference using the formula a sub n equals a sub 1 plus n minus 1 times d. We have a sub 5 equals 3 plus 5 minus 1 times d. Simplifying, we have 27 equals 3 plus 40. Simplifying further, we have 27 minus 3 equals 40. That is, 24 equals 40. Therefore, D equals 6. The last term of the sequence is not provided, so simply make use of the data available. First term, a sub 1 equals 3. Common difference, b equals 6. And number of terms, n equals 26. Now, let us use the formula for an arithmetic series, that is S of n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. So, we have S of 26 equals 26 over 2 times 2 times 3 plus 6 times 26 minus 1 equals 13 times 6 plus 6 times 25. Simplifying, we have 13 times 6 plus 150. So we have 13 times 156. Therefore, the sum of the first 26 terms of the arithmetic sequence is 2028. Let us have a word problem regarding finding the sum of arithmetic sequence. Let's consider the following problem. Hans savings. Since January, Hans has always wanted to buy a new cell phone. When he went back to school after the Christmas break, he started saving some money from his allowance. He was able to save 500 pesos on the first month. He continued saving and he was able to save 700 pesos in February, 900 pesos in March, and 1,100 pesos in April, and so on. First question. How much money did he save on his 5th month? Given the arithmetic sequence showing Hans' savings in the past 5 months, arithmetic sequence is 500, 700, 900, 1,100, 1,300, and so on. Using the formula S of n equals n over 2 times a sub 1 plus a sub n, we have S of 5 equals 5 over 2 times 500 plus 1,300. S of 5 equals 5 over 2 times 1,800. Therefore, S of 5 equals 4,500. Hans saved a total of 4,500 pesos after 5 months of saving. Second question. Hans wants to buy a cell phone worth 13,500 pesos. Would he have enough money to buy the cell phone after 10 months of saving? Let's see. Let's look into the solution. Using the second formula for an arithmetic series, we have S of n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. We have S of n equals 10 over 2 times 2 times 500 plus 10 minus 1 times 200 equals 5 times 1,000 plus 9 times 200 equals 5 times 1,000 plus 1,800 equals 5 times 2,800. Therefore, S of n equals 14,000. So, Hans will be able to save 14,000 pesos after 10 months of saving from his allowance. Since the cost of his desired cell phone is 13,500 pesos, he can buy his new cell phone after the 10th month and can keep the remaining 500 pesos as his savings. Now, it's your turn to answer some problems and finding sum of arithmetic sequence. First problem. Find the sum of the arithmetic sequence 6, negative 1, negative 8, negative 15, negative 22, negative 29. What is your answer? If your answer is negative 69, then you are correct. Second problem. Find the sum of the arithmetic sequence 7, 3, -1, -5, -9, -13, -17. What is your answer? If your answer is -35, then you are right. Third problem. Find the sum of the first 20 terms of the sequence 3, 10, 17, 21, 24, 31, 38, and so on. What is your answer? If your answer is 1,390, then you are correct. Next problem. What is the sum of the first 15 terms of the sequence 16, 27, 38, 49, 60, 71, and so on? What is your answer? Indeed, the answer is 1,395. Before we end, let us summarize what we have learned today. First, the terms between any two non-consecutive terms of an arithmetic sequence are called arithmetic means. Second, if A, T sub 1, T sub 2, then T sub m, then B form an arithmetic sequence, then T sub 1, T sub 2, until T sub m are the arithmetic means between A and B. Third, an arithmetic series is the sum of the terms in an arithmetic sequence denoted by S of n. Fourth, the sum S of n of the first n terms of an arithmetic series is denoted by S of n equals n over 2 times a sub 1 plus a sub n, or S of n equals n over 2 times 2 a sub 1 plus n minus 1 times d, where a sub 1 is the first term, a sub n is the nth term, n is the number of terms, and d is the common difference. That's all for today, my dear learners. I hope you learned a lot from today's session. See you on our next episode. Always remember to stay safe and enjoy learning mathematics. Again, this is Teacher Xiao. Have a good day and keep safe, everyone. Goodbye.